kernel-based virtual machine, or KVM as it is more commonly known, is a Type 1 hypervisor which allows for direct communication between the hypervisor layer and the hardware without the need for emulation. Other Type 1 hypervisors that you may already be familiar with are VMware ESX, Microsoft Hyper-V, and Citrix Xen Server. KVM was merged into the Linux kernel mainline since approximately 2007, and almost all Linux distributions have the KVM module as part of its Linux kernel package, thus allowing multiple virtual machines to run unmodified Linux and Windows images while sharing the same hardware. So how does KVM VM protection compare to other virtualization protection approaches? The most popular virtualization solution is of course VMware, so let us start by doing a level set of that approach. With multiple ESX hypervisors, we can provide our virtual server agent individual ESX host credentials, and we can communicate directly with these hosts by leveraging the v80p API residing on our agent. This would of course mean that each host would be represented as a unique client, and this is commonly only used in small environments as it can have significant management implications as these environments grow. A much better and more prevalent approach is to use vCenter credentials and authenticate via the centralized management entity, and then make the necessary calls to gain access to the appropriate virtual machines. So now the question is, how do we interact with KVM? First, let's start with our current supported solution for Red Hat Enterprise Virtualization. Unlike ESX hosts, we cannot use a direct hypervisor communication method since there is no API mechanism to do so. To talk to KVM hypervisors, we will need a centralized management component like the overt engine and the appropriate API mechanisms such as VDSM for the KVM hypervisors to understand the necessary calls. What is overt and VDSM? Overt is a free open source virtualization management platform. It was founded by Red Hat as a community project on which Red Hat Enterprise Virtualization is based on. In short, Red Hat Virtualization Manager is simply the downstream, stable version of Overt. VDSM is a daemon which is required by virtualization managers such as Overt Engine or Red Hat Enterprise Virtualization Manager to manage Linux hosts and their KVM virtual machine guests. With this in mind, let's take a look at how it all fits together. First, Commvault's virtual server agent must be a virtual machine. This is because Red Hat Enterprise Virtualization only supports a hot add methodology for VM protection. Now it is important to note that this could be a virtual machine running Windows, or it could be a virtual machine running Red Hat Enterprise Linux. This is the first iteration of our virtual server agent running on a Linux client. Next, we need that management component that was previously described. This is the RHEV manager that is built on the Overt engine, and it plays a role similar to what vCenter does in VMware. After that comes the API layer. This is the Virtual Desktop and Server Manager, or VDSM for short, and it can be installed via an RPM on the individual KVM hosts. At this point, all the pieces required to perform a protection operation are in place. From here, the virtual server agent is able to talk to RHEV Manager server via the RESTful API. It calls for virtual machine snapshots to be created, so to freeze I/O on the necessary VM disks. These can then be mounted to one or multiple VSA proxies and the contents streamed out to our content store. This is the basic view of our current Red Hat Enterprise Virtualization Protection solution, and documentation is currently available in books online that goes further in depth. What happens when there is a KVM environment that is not a Red Hat Enterprise Virtualization environment? Let's say it is a CentOS environment, or SUSE, or Ubuntu, or any other modern Linux distribution that supports KVM. Because under the covers RHEV Manager uses the Overt engine, the API calls should be the same when running the equivalent Overt version that Commvault currently supports for RHEV. Assuming all things being equal, this configuration will be eligible for field certification. So how does KVM work under OpenStack? When KVM hypervisors fall under an OpenStack cloud, the OpenStack Hypervisor Management APIs, or Nova Compute, are installed directly on the KVM nodes themselves. This is not always true of all other OpenStack supported hypervisors, which gives KVM a unique advantage. When Nova Compute is present on the KVM nodes, Overt and VDSM is not compatible and an alternate VM protection methodology must be used. To find out more about OpenStack VM protection, please reach out to products@commvault.com. In many scenarios, however, customers will have both OpenStack for their cloud solution running in parallel with Red Hat Enterprise Virtualization for their not-so-cloud-friendly production workloads. There are a number of advantages of having both of these solutions running in parallel, as OpenStack offers services that are able to interoperate across both of these platforms. One of these is the Glance image service. OpenStack Glance offers the ability to have a single template repository that can provide VM images to both OpenStack and RHEV environments alike. Another shared service is Neutron. Neutron offers distributed networking across your OpenStack and RHEV KVM hosts, allowing them to share pre-established networks and switches across both environments as a whole. Additionally, Red Hat's CloudForms can also span both environments to offer VM and host provisioning. Thank you for watching, and as always, please direct questions to products@commvault.com.